All right, we're going to go through the Section 1 exam review. I'm going to do the first chapter only right now, which will get us through question 16. Alrighty, jumping in. Make a bar graph of the types of vegetables boys like. So we're only looking at the green here. Just a reminder, bar graph, the bars do not touch because this is categorical data. Everybody pick their favorite. I'll abbreviate, so we'll do BR for broccoli, excuse me, C for carrots, there's two C's, CA for carrots, CO for corn, peas, and squash. The highest frequency that I see is 10. So let's just speed it up and go 0, 2, 4, 6, 8, 10. And then we're just going to make the bars the right height. So the broccoli bar is only 2. Carrots was 6. Bars don't touch again in these charts. Corn is the most popular. I don't know about that. Not much, well, I guess sweet corn I do like. Squash, 5. So there's your bar graph. Okay, and this was again only the boys. Number 2, a segmented bar graph could be done 2 ways. Well, actually, I take it back. It says with the vegetables listed on the x-axis. So with this direction, I know that I'm going to put the vegetables across the bottom. CO, CA, peas, and squash. And we want then for broccoli to have a bar and determine for broccoli what percent of broccoli is preferred by boys and then by girls. So I'm gonna do mine as relative frequency on the side. If you did just frequency, I guess you could do that, but the nice thing about relative frequency is it is going to streamline. It'll keep it the same for all of these, meaning I only have to get up to 100%. So I'm going to go 20, 40, 60%. Now let's see, can I spread that out? Let's go 0, 20, 40, 60, 80, and then do the very top will be 100. So what I was saying was, now that it's based on percentage, all my bars will be the same height, but because if I did it on just raw quantities, there's only 7 that shows broccoli, there's 13 that shows carrots, but then I'd have to get up to 18 on my side here, on my Y scale, and I don't want to do that. So got my bar for broccoli. In fact, I'm gonna just copy this bar and paste it for every vegetable. And then my task is to, for each one, more or less shade in what percentage are boys and what percentage are girls. So for broccoli, if I'm looking at just broccoli, the boys would be 2 out of 7. Let's get a calculator going. 2 out of 7 is 28%. I guess that would round to 29. So we'll say 29%. So I'm going to change up my color here. Let's highlight green. And so the boys would be here, about the first 30%, we'll say. And then I could do, I don't know, orange for the girls. And on the side over here, I would have a little key. that people reading this know what's what. So the green would be the boys, and the orange would be the girls. And then I'm going to carry on like that for every vegetable. Carrots, the boys were 6 out of 7. Oh, not 7. The 6 plus 7 is 13, so there's 13 total people. Boom, 46%. Well, we'll be comfortable just rounding it. So for carrots, ooh, I just noticed I switched corn and carrots on the bottom. I want to stay in the same order. Corn first, carrots second. 46%, just we'll go a little bit less than half. So something like that for the boys, and then the rest would be a little bit over 50%. But it's pretty close to an even split. For the corn, it's 10 out of 18, which, let's see, that's 5/8, which is 62.5%. I just happen to know that one. So just a little bit above 60%. Oops, wrong color fag. The boys. And then the girls on top. Okay. And continuing on like that, peas. The boys are 8 out of 13. About 62, we'll say. Peas, just above the 60% line. Kind of putsy, but not overly difficult. Squash, 5 out of 11, which will be a little bit less than half, 45%. Right about there. There we go. All right. Excuse me. And I already answered number 3. Is this is the vegetable type category or quantity? It's a category. If you are answering this survey, you're not giving a number answer, you are giving a category as an answer. Name something that is quantitative. Well, shoot, we've done this a lot in class. This could be your height. This could be your hourly pay at work. Anything where the answer is numerical, okay? Numerical. All right. Answer the following questions below. What percent of boys prefer broccoli? So this is a condition. We're only looking at the boys. We already kind of answered this, by the way. What percent of, or no, sorry, we didn't. We need, what percent of boys prefer broccoli? Only 2 of the boys prefer broccoli. How many boys are there? I have to add all of these up. 2 plus 6 is 8. Plus 10 is 18. Plus 8 is 26. Plus 5 is 31. So I've got 2 out of 31. So only about 6% of the boys. I'll do squiggle, 6%. Part B, what percent of the peas were preferred by girls? So now the condition is peas. So I'm only concerned with the orange here. Only 13 people preferred peas. Of those 13, how many were girls? And it's 5. If you want to change that, you can. Change it to a percentage, you can. Leaving it as a fraction is totally acceptable. What percent of students prefer corn? There's no condition here, just of all students, right? So I need the grand total. I already know there's 31 boys from before. Let me start adding in the rest of the girls. And I got 62. Let's see if I did that right. Yep. And how many of them preferred corn total? That was 18 people that preferred corn. So I'm at 18 out of 62, which is about 29%. What percent of students are boys and they prefer carrots? So this is like, of all the people in this chart, I'm only focused on the boys that like carrots. That would be these 6 right here. There's no condition here. Like here it said I have to pick a boy, essentially. Here I had to pick someone that likes peas. For part D, there's no condition. It's just what percent of all the students are boys and they like carrots. So that was just 6. 6 out of the grand total of 62, which is about 9%, closer to 10%. 6 out of 62, which is 9.7%. All right, naming these curves. This one is symmetric because it's got symmetry around the middle. This one is skewed right. Then this one is skewed left. This one, maybe if you put more like bars in here, if it was a histogram, they are all the same height, so we call that uniform. This one has essentially 2 pieces of data, so it's bimodal, or sometimes we say double peaked. All right, page 1 in the books. Create a dot plot for the baseball data. Oh. Wait a minute, got a little bit out of place here. It wants a dot plot for this data down here. I think we'll make do, okay? The number of runs and the frequency. So I'm just gonna say 0, 1, 2, and 3, and 0 runs were scored 4 times, 1 run was scored 3 times, and then these were each scored once. That's a dot plot. And then you should say, with a label, this is the number of runs. 8, create a frequency histogram on the left side. So we're kind of just, I don't know why that got moved down here, but we'll deal with it. With the number of runs. So 0, 1, 2, and 3 runs. And up the side would be frequency. The highest frequency we had was 4, so this is pretty easy. Just 0, 1, 2, 3, 4. And 0 runs happened 4 times. 1 run was 3 times, and then 1 time. So that is, sorry about the format here, but that is the left side of the graph. 9 is an ogive, which is a cumulative relative frequency. We're going to do that over here. Let me just change color so it kind of stands out. So here's my new y-axis. In fact, I want to move that over. No, I'll leave it there. I think I'll move this thing over. Okay. In an ogive, the numbers up the side are percentages. So 20%, so on, 40, 60, 80, and 100. Okay, these are percentages. And then you've got the games. You've got 0, 1, or sorry, the number of runs. So when I start here with the 0, what percent of games were 0 runs? So how many games did I have total? Add these up. 4 plus 3 plus 1 plus 1 is 9 games. 9 games. So for 0, the percent of games that had 0 runs or less is 4 out of 9. And that's 44%. Okay? So I'm going to try to make my bar for that about 44%. Okay? You could do this, maybe zoom in and put 44 if it helps you to remember what that was. Now, when I go to the 1, it's not just 1 run, it's cumulative. Cumulative So it's 1 or less. So it's both of these. It's 7 games. So that would be 7 out of 9, which is 77%. You can take a calculator and divide if you need that. 77%, oops, I went too far. Just under 80, right? And that would be that. 77% of the games had 0 runs or 1 run. 2 runs per game would be 2 runs or less per game, sorry, would be 8. And 8 out of 9 is 88%. So that goes, well, to somewhere in there. 88. And then the last one goes up to 100 because every game, excuse me, got a scratchy throat. Every game was 3 runs or less, 100% of the game. All right. Now, oh man, this got all messed up. Number 10 is we're going to take the data shown and construct a regular stem and leaf plot. This is the data down here. I'm sorry, it's all over the place. We're not going to do the split stem and leaf plot, okay? We're just going to do the regular. This is pretty intuitive once you get going. You put this is the tens place, and then you put the ones place across the way. Let me give you a shortcut here, because when I looked at this, I was like, this would be a whole lot easier if this data was in order. So I have the numbers in my calculator. I went to Stat, Edit. They are over here. They're in list 1. Okay. You can have your calculator sort these. You hit Stat. Then when you see right here, option number 2, sort A. And number 3, sort D. Sort A is ascending. So if you do sort A and then list 1, it will sort it in order for you. It says done. Now if I go back to my list, it will be sorted. It's in order, and that will help me or you to do the stem and leaf plot a little bit quicker. Okay, so there's only one number in the single digits. There's a 13 and a 14, and this is how the stem and leaf plot rolls. And then you can just pretty quickly go through that, because there's 3 numbers in the 20s and so on. Most of the numbers are in the 30s. There's 4 32s. And there you go. Gonna put a key. Would be like 4 bar 3 is 44. Okay, we're gonna skip the split one. Okay. Number 11 says, for the data, find the mean, the median, the mode, and the range. So for that, I'm going to use my calculator. Stat, calculate, and I'm going to do number 1, variable stats on list 1. And there you go. Makes it pretty darn easy. So the mean is 3305. Median, you got to go down for the median. Oh, no, I don't. Not on this calculator. On your calculator, I think you got to scroll down. And the mode is not given to you, but you can tell what it is by looking right here. There were 4 32s, which is by far the number that occurred the most often. The range, sorry about this formatting, is the maximum minus the minimum, which is the largest number is 57 and the lowest number is 2, so the range is 55. Okay. All right, number 12 says, let's describe this data using SOX. So reminder, SOX is shape. center, spread, and outliers. All right. The shape. Well, we haven't graphed it yet. Well, I guess we have. In a way, we have this stem and leaf plot. If you do this, and then kind of turn your head sideways and look at it sideways, most of the data is in the middle, and it's equally split on either side. So it is approximately symmetric. You could also do this, by the way, on my calculator. Boop, boop. Go into the stat plot menu. I apologize, this one looks a little bit different than yours. But select histogram, and then graph it. Zoom 9, or is zoom stat. There it is. It's kind of symmetric. The tallest bar is in the middle. There's a weird gap in the middle, but I think you can still say that's approximately symmetric. The center is the safest number to use is the median, centered at 32. In this case, the mean and the median are pretty close, and they're pretty close because this data is fairly symmetric. And when it's symmetric, the mean and the median are both in the same spot. Spread is the standard deviation, or the range, or the IQR. We already found the range, so you could say that the range is 55. Range of the data is 55. You could also, go back to my calculator, you could pull the standard deviation out of the calculator. It's the SX because this is a sample. So it's the 14.177 number. And I'm going to just put that down too. Standard deviation is 14.177. Outliers. It doesn't look like there's outliers because it's pretty tightly grouped, right? When you turn it sideways, there's no dot, like it's not skewed like this one way or the other, and I would say no apparent outliers. You can also cheat on the calculator, and you can have it do the work for you. Remember, if you go to your stat plot menu, one of the options is this guy, the box and whisker plot with those plus signs, which when we graph it and do zoom 9, there it is down there in the bottom, but the whiskers are complete. Oh, just kidding. See that dot down there? That square dot down there? That is an outlier. So I was wrong. So I could go back here and say, just kidding, JK. 2 is an outlier. Which, it's small enough to be an outlier. All right. Onward and upward. What happened to the rest of my... I guess we're stopping there, folks, because that's all that got put into Notability. So I'll stop